Hello everybody, welcome back to another series on mathematical derivation. And in the last video, if you guys recall, we did one example of Larange interpolation. So in today's video, I'm going to show you guys why did we came to the Larange formula in the first place, what's the motivation behind it, and how do you get it without any memorization. So let's go ahead and get started. So if you took numerical methods class, and I didn't speak for all methods in that class, I speak for a few of them. But usually it's like this. It's usually start with some horny mathematician. They want to turn everything into polynomials because polynomials make your life easier and it's very easy to compute, solve for the root, compute derivative, and do everything. That is basically the main idea. You turn every function to a polynomial. So how do you express that in paper? So let's say you have a function fx, right? And you want to turn it into a polynomial. So what would the polynomial looks like? It would look something like this. If you recall from Taylor series, your polynomial would look something like this. It would look something like if we have a0 times x minus x0 to the power 0 plus a1 times x minus x1 to the power 1 plus on the way to an x minus xn to the power of n. Correct? Oh, actually, no, it's not x0. I believe it's like, I think it's a something. Yeah, it's a. Yeah, it's a. Okay, this is Taylor series, if you recall. And then, so Larange is a little bit different. So Larange is, you have a function, right? You also want to turn into a polynomials, but the polynomials form is a little bit different. It looks something like this. It looks like, so it's a coefficient a0 times x minus x1, x minus x2 times on the way to x minus xn plus coefficient a1, a0, capital A0 and capital A1 are coefficient, and I'm gonna show you guys how to find them later. Okay, so notice this. If you have a1 here, you won't have x minus x1 on your on the whole multiplication thing, similar to the left side here. I don't know, I cannot see a laser, so I'm just gonna, so you have a0 here, you won't have x minus x0. Okay, so you just notice that. So a1 is x minus x0 times x minus x2 on the way to x minus xn. Okay, and then plus on the way to an of x minus x0, x minus x1 times on the way to x minus xn minus 1. Okay, this is the Larange interpolation. Okay, so how do you find a coefficient? A0, A1, A2, A3, A4, all the way to AN. Okay, let me write in blue. How do you find the coefficient? So find for A0, what you do is you compute f x0. What would it be? It would be a0 times x0 minus x1, x0 minus x2 on the way to x0 minus xn plus a1 times x0 minus x0 times x0 minus x2 all the way to x0 minus xn. Notice that I just plug in x. I'm just plugging x0. So, and then you plus on the way to an. I just replace x with x0. That's it. Let me make it here clear. X, I replace it with x0. So x0 minus x0, x0 minus x1, all the way to times all the way to x0 minus xn minus 1. So you notice something. Okay, so this thing is 0, right? So all of this vanished just like a Thanos snap. Okay, and this also x0 minus x0, this becomes 0. So all of this, kaboom, go away. So you have what? You have f x0 equal to a0, x0 minus x1, x0 minus x2, time all the way to x0 minus xn. So to solve for a0, you would divide both sides by x0 minus x1 times x0 minus x2 times all the way to x0 minus xn. Okay, this is how you find a0. And similarly, if you want to find a1, you can plug in x1. If you want to find a2, you can plug in x2. So yeah, so that's basically the Taylor series. So how do you write it? The Larange interpolation. So how do you write this in terms of fancy Greek sigma term? I mean, mathematicians, they don't have enough paper, right? In real life, you don't have, your paper is not like this, my OneNote right here where you can write all the way here. There's limit. So they introduce some Greek notation into it, right? So how do you write it that way? So this is f. So remember fx. I'm gonna write this a0, and let's check time. Okay, I have 3 minutes, no problem. x0, x minus x1. Oh, sorry, no, there's no such thing. X, there's no x0, so x1, x minus x2, xn. Sorry, on the way to xn plus a1, x minus x0, x minus x2, and all the way to x minus xn plus let me 0, x minus x1, way to x minus xn minus 1. Okay, so how do you write this? So fx, it's a summation, right? So it's the summation of k equal 0 to n of a0. You replace this term by, you have to think generally. So instead of a0, you have xk over xk minus x1, xk minus x2, on the way xk minus xn, right? And then you times x minus x1, x minus x2, on the way to x minus xn, right? And you know that one thing, you know that this term right here, on this multiplication right here, does not include xk minus xk, right? And this term right here does not include x minus xk, correct? So instead, beside the sigma term right here, we have to introduce another term which represent the multiplication of the whole series. So I'm gonna rewrite this as fx equal to summation of k equals 0 to n fxk times, this is x. I'm gonna have to introduce a new Greek notation, which is pi. I'm gonna recite x minus x m from 1 to n, and m is not k. It's different from k. Similarly, this is, I'm gonna introduce in the same here. So m, and I'm gonna j equal 1 to n, and then j is not k, xk minus x. Oh shoot, it's not 1, it's actually start from 0, sorry. It's actually start from 0, 0, 0, m. Sorry guys, it's not k, and it's x. Okay, so here is a formula for the Larange Interpolation. I hope you find it helpful. And yeah, that's the motivation behind it. I actually watched an Indian video. An Indian guy explained very well. I just clarify a little bit, and may add some floury stuff into it, add some saute. You can say, even though I'm not Malaysian, I love your dishes. Yeah, you add some spice into it. So yeah, so I hope you find the video helpful, and in the next video we're gonna actually derive the Simpsons integration using this. So the Simpson integration, I give you a hint, we actually derive using Larange. Okay, but I'm gonna cover this in the next video. I'm gonna arouse you guys for now. To look it up and even figure out yourself. And but the next video I'm gonna show you how to get the Simpson integration formula. Okay, I wish you have a good night and take care.